Hello friends, today we will be starting with a new chapter or a new section in the balancing, that is balancing of reciprocating masses. So far we have studied or we have looked at what is balancing of rotating masses, how it is done by using force polygon and couple polygon or by analytical method by taking horizontal and vertical components of forces and couples. So we will be starting reciprocating masses because reciprocating masses are more normally associated with engines. Questions are normally of engines or crank piston arrangements. So consider a slider crank arrangement here, and we will go straight to the forces acting on this. So we know in order for the piston to reciprocate, there should be a gas pressure or a reaction force to accelerate that piston. So let's take that force as Fr. Let it be acting on. Sorry about that. Yeah, let it be acting on this direction, and that is Fr, R for reaction, and there will be an equal and opposite inertia of that reciprocating piston acting on the opposite direction. That we can take it as Fi. And since piston is rotating inside the cylinder, there will be a reaction in cylinder walls which is acting normally. Let's take it as Fn, or take it as F capital N. Yeah, Fn. And these are the three forces acting on the piston side, and there will be one more force acting on this crank side because this crank is rotating in a bearing. There will be a bearing, so taking that crank, and there will be a force exerted on this bearing when it rotates, and let's take that force as Fb. And if it is rotating at an angle theta, then Fb will have two components. One will be the vertical component and the other will be the horizontal component of the Fb. So Fb horizontal marked Fbh and Fb vertical, let it be Fbv. So to sum up what are the forces shown, these are the forces shown. Fr is the force required to accelerate the reciprocating parts. This may be equal to gas pressure. And Fi is the inertia force due to reciprocating parts. Reciprocating parts means mainly piston, and Fn means the force on the sides of the cylinder walls or normal force acting on the crossheads or guides. Guides means cylinder walls itself. When it is an engine, we call the guides as cylinder walls or cylinders. And Fb is the force acting on the crankshaft bearing or the main bearing. If it is an engine, we call it as crankshaft bearing. If it is anything else, we can call it as main bearing. So these are the forces acting, and this we can see that F R will be always be equal to Fi. So these forces are balancing each other. So there will be no unbalanced force created by this one. So we need not balance this one. This is not required to be balanced. This will be balanced. But there are three forces left. One is the normal force, other one is the horizontal component of bearing, and third one is the vertical component of bearing. We don't consider Fv because we have already considered the components of that. So three forces Fn, Fbh and Fbv are still there. Let's see Fbh. This Fbh will act in a horizontal direction, and it will create a vibration or the unbalanced nature, and it is an unbalanced force, and we call it as shaking force. Fbh is known as shaking force because it will create some vibrations onto the mechanism. Fbh, horizontal component of bearing. Now you see these two forces. Fn is acting vertically, Fbv is also acting vertically. And let it be separated some by some distance x, let this be x, then it will create a couple, two equal and opposite forces acting on between a distance or separated by a distance. So it will create a couple. So Fn and FBV creates couple, and that is an unbalanced force or couple, and it is known as shaking couple. So we have learned what is shaking force, and we have now learned what is shaking couple. So the objective of this balancing of reciprocating masses is that we should balance this reciprocating masses by balancing the shaking force and shaking couple. Both are unbalanced. This will create some vibrations on the